Well, howdy there, Internet students. Mr. Hermanson again. Say we're going to do lesson 7.2a, which we're going to concentrate on figuring out the slope. Okay. To help us do that, we're going to look at this graph. This is on your second page, but I'm going to just have it handy here so we can answer this. And so we want to look at this picture, and this represents the distance from the intersection on the y-axis. We're going to call that the d-axis, and then how long it takes to get there. Now, you guys, some of these cars are actually going towards the intersection, and some are going away from it. In other words, some are at the stoplight and leaving the intersection, and some are going towards the intersection. And we can tell that by the distance, by whether the arrow is going, the distance is going up or the distance is going down. Okay, and you can see from the arrows by that. And what I mean by that is like this black arrow is, notice that it's going down from left to right. So if you're at the intersection, that means you're at 0. That's right here. You're at the intersection. Okay, so the black over time, 1 second, 2 seconds, 3 seconds, it's getting closer and closer to the intersection. So the black car is going towards the intersection, while the orange car is actually going away from it, because notice the distance starts a little less than 60, but after every second the distance is getting higher. So that means that car is going away from the intersection. All right, so go ahead and fill in the rest of those, right? Whether they're going towards or away. All right, the red line is very steady. It's always 100 meters away from the intersection. So it could be something like it's parked. Maybe it's at another stop sign, who knows. But so I put neither for that one. The green one is going away because it starts at a distance of 0 and that distance keeps climbing. The white one is going towards because the distance is getting less and less from the intersection, but then it stays the same for a while. So maybe it got somewhere and parked and it's always stuck that distance away. The blue one is going away from the intersection at first, and then it seems to stop at that distance, so it's probably parked. So maybe there's a parking lot nearby that all these cars are going to. And the yellow one is going away from the intersection also. All right. Now, you guys, we're going to talk about the slope. If it's going towards the intersection, then those lines where the distance is getting less and less, like the black line, those are going to be negative, decreasing relationships, negative correlations. So that means that we're going to write those slopes as negative. If it's going away from the intersection, we're going to write those slopes as positive because that's an increasing situation. All right. So the black line, and here's how you're going to find it. I'll do a couple with you and then I'll let you do it. The black line, what we need to do is find 2 points on the line where it's right on the grid. And that's not too hard to figure out on some of these, but you'll notice that the black line matches these dots pretty good. Okay, which means that in 1 second time, the slope is dropping. So we're going to look at these. So here's 1 second. It's going down 20. Okay, so the slope is rise over run. So when you make those 2 lines in, the rise will be your vertical line and the run will be your horizontal line. And then if it's going towards the intersection, then it's going to be a negative slope. So the black line is a negative 20 for the slope. And it's actually negative 20 over 1, but since it's over 1, we just write negative 20 for that one. Now the orange one is going away, so that's a positive slope. And it looks like it's not quite, well, I guess it's pretty close to, we can look at these dots on the orange line. Okay, it looks like it's going up, draw a vertical line up and then over 1, so it's up 20 between 60 and 80 and over 1. So that would be 20 over 1, and it's positive because it's going away from the intersection. Okay, so go ahead and do the others and see if you get them right. All right, here's what I got on those. Your numbers might be a little different depending on where you found the spots on the graph to do them. I'll just go over a couple real quick. Like the blue one, I noticed from here to about here. So going up from 20 to 80 is 60, and then over 5. So that's how I got that 12 there, and it's a positive 12. For the yellow one, I went from the bottom of the graph to where it stops at the parking lot there, and I figured that was about 160 because we went from 0 to 160. So we went up about 160. I went all the way to this line. It's a little below that line, but I think that's all right. About 160, and then that's over 7 seconds. Okay, and that's a positive number. All right, now the car speed, to get their speed, you do distance divided by time equals the rate. And distance is your rise. And the time is your run. So the numbers that you use to get the slope in the last problem, you can also use to get your distance. So the black, and when you do, I mean, to get the rate, you're not going to have a negative rate. You know, it doesn't matter whether they're going towards the intersection or away. So the black car is going 20 meters per second. The white car is, we're going to do 40 divided by 3 for that one. So that's 40 meters divided by 3 seconds, so about 13.3 meters per second. Go ahead and write down the speeds for the rest of them. All right, so here's the speeds I got, and all I did to get those is use the slope and divide out those numbers. Remember, that's always meters per second, and those numbers should always be positive, even if the slope is negative. Okay, number 4 says 3 cars drove to a parking lot about 160 meters from the intersection park. What color of those cars are there? Go ahead and answer the last 3 questions here, and then you can check back and see if you got them right. All right, here's the answers to those. You can tell this one because the line is flat. So it's not moving, and you can tell the 2 that crossed at a time equal to 4 seconds. Just look at 4 seconds on the graph until you find the 2 that cross, and there they are right there, the black and the green ones. All right. I think that's all we got for this lesson. You can go ahead and work on finding the slope. Remember that slopes can be positive or negative, but if we're talking about the rate that those slopes create, those need to be positive. All right, good luck with that. Talk to you soon.